Hi, I'm Kathy Stark. In this lesson, we define a one-to-one function, we define an inverse function and how those two are related. We look at how to calculate an inverse function and how an inverse function and its function are related. Let's begin with one-to-one function. By definition, a function is one-to-one if for elements a and b from the domain of f, a not equal b implies f of a not equal to f of b. Here's an example. We want to determine whether this function, negative the cube root of x plus 5, is one-to-one. We start, as the definition says, with the statement a not equal to b. And now I'm going to try to build this function on both sides. If a is not equal to b, a plus 5 is not equal to b plus 5. Now the cube root. The cube root of a plus 5 is not equal to the cube root of b plus 5. Now the negative. Negative the cube root of a plus 5 is not equal to negative the cube root of b plus 5. If a is not equal to b, this is not equal to that. The piece on the left is f of a, on the right is f of b. And I was able to conclude that f of a is not equal to f of b, so this is a one-to-one function. Let's try another example. Let's determine whether this function is one-to-one, and this time we have negative the square root of 100 minus x squared. We'll begin in the same way with the statement a not equal to b, and I want to build this function. So the first thing I need to do is square both sides. However, if a is not equal to b, it's not necessarily true that a squared is not equal to b squared. If a is 2 and b is negative 2, their squares are both 4. I'm not able to conclude that f of a is not f of b, so this one is not one-to-one. Let you have a chance to work with the definition. Here's what I want you to do. Determine whether this function is one-to-one. Stop the tape, then restart it to check your work. Let's see how you did. You should have begun with the statement a not equal to b. And we're going to build this function. So the next step is to say a minus 2 not equal to b minus 2. And now we need to square both sides. But as in the previous example, this statement does not necessarily follow from the one above. So this function is also not one-to-one. There's another test for a one-to-one function if you're given its graph. This is the test. It's called the horizontal line test. If every horizontal line intersects the graph of a function in no more than one point, then the function is one-to-one. Keep in mind horizontal line, and here's an example. What we want to do is determine whether this function is one-to-one. What we need to make sure is that any horizontal line drawn in the coordinate system will intersect that only once. Since that's the case, this is a one-to-one function. Well, we're starting to connect now, or we're going to connect now, one-to-one functions to inverses. Let's start with this particular piece of information. I want to let f be a one-to-one function. Then we say g is the inverse function of f if the composition f composed with g of x is x for every x in the domain of g, and the composition g composed with f of x is x for every x in the domain of f. Let me use this statement in this example. What we're going to do is decide whether the functions in the given pair are inverses of each other. According to the rule, I need to find f composed with g of x. That means take f and put into it function g. In this particular case, where the x is, I'm going to put 1/2 x minus 2. 2 times 1/2 x minus 2, then plus 4. Distribute the 2 to get x minus 4 plus 4. The 4's add to 0, and I get x, which is part of what I needed. I need that to work in the second composition. Now we'll find g composed with f of x. That means take function g and put function f into it. For these two functions where the x is in function g, I'm going to put all of function f. 1/2 times 2x plus 4 minus 2. Distribute the 1/2 to get x plus 2 minus 2. The 2's add to 0, and because these two values are exactly x, not the same but exactly x, the functions f and g are inverses. I'd like you to practice this. Here's what I want you to do. Decide whether the functions given are inverses of each other. Stop the tape and work this problem, then restart it to check your work. Let's see how you did. Here are the two functions. Let's find f composed with g of x. Again, that's f with g substituted for every x. I'm going to put x plus 8 over 7 in for x to get 8 times x plus 8 over 7 minus 7. Now when I distribute the 8, I'm going to consider it 8 over 1 and multiply the 8 by the numerator and the 1 by the denominator to get 8x plus 64 over 7. There's no way to simplify this to the variable x. Therefore, we have to conclude that this f and this g are not inverses or inverse functions. Well, what we'd like to be able to do is find a rule for an inverse function. First, we need to introduce some notation and a little bit more information about a function and its inverse.